going to look at graphing today. And what we're going to do, let me get the blackboard on here. Sure we can see. Sorry, you're seeing some of my desktop here. There we go. And there are some different types of graphs that we need to be aware of and how they work out. So, the first type of graph is a pictograph, which uses pictures or symbols to represent a quantity. And these are great to make quick visual comparisons, but it's hard to discern exact quantities out of them. So, for example, if we look at the space exploration, from 1957 to 2019, we can make a pictograph of rockets. So we'll make our pictograph of rockets here. And not quite a full rocket on the end. It's kind of cut in half. And each rocket equals 7 space flights. And we'll do the former Soviet Union. What's nice about this pictograph is it's easy to see the Soviet Union had more space flights. This extends further out. But it's hard to say exactly how many because I'm not sure how much that fraction of a rocket is. If each rocket, full rocket, is 7 space flights, and I have this fractional rocket here, then we have what, 12, so that's 84 space flights plus a little more. And here we have at least 21 more because there's 3 full rockets here. And so pictographs are really nice. They give visual information quickly without worrying about exact quantity. And visual information is the key. Um, we can approximate the number that the U.S. had. There's 12 full rockets and about a half. So we could say that 12 and a half times 7, and that's approximately, well, I guess we could do that as 12.5 times 7, and that's 5, carry my 3, 7, carry my 1, 87.5. So, and since we know we have less, we'll round down to approximately 87 space flights. So notice we rounded down because we know we have less. And we could also look at how the these extra space flights came into play. So there's a half here, so we have 3.5 more. So the USSR had 3.5 times 7, or 5, 24.5. Again, because we're not sure, we'll do a round down to be sure. And the USSR had 24 more space flights. And so pictographs are a good way of taking quantity and turning it into something that covers space. And that's going to be something we're going to see with all the graphs that we do, is that we'll turn quantity into something that covers space, and we'll let our intuition on what is more, what covers more space, be our guiding line. So another type of graph is a bar graph. And this really is a pictograph with a little more of an ability to define quantity. So let's see here. Let me put my scale on my graph. So what we'll do is we'll see categories at the bottom of the graph, and then we'll see a bar representing how much each category has. It's a general idea of a bar graph. So let me label these. This is a quantity of a count going up. We'll later call this the y-axis. And we'll call this the x-axis. The ability to move in one direction. But for right now, we have a quantity one side, and then we'll have a category. And so the one we're going to look at is endangered species in the U.S. So we have amphibians, birds, fish, insects, mammals, and reptiles. And if I look, let me see if I can make this right. Number of endangered amphibians, we would fill in like this. And the number of endangered birds. Let's see if this fills in correctly. And the number of endangered fish. And let me fill in each of my insects. Mammals. And reptiles. And so a bar graph has bars in it, and the bars measure to an exact quantity. You could measure a ruler to match the number on the side. And we can use this to approximate. So we could say how many fish are endangered, and fish are around 90. There's about 90 species of endangered fish. We could compare that to birds, which are about 78 species. And if we zoomed in closer and closer, we would get an exact number. And in this, our fish have are the most endangered in America. And so bar graphs use bars to measure a quantity, and it measures like a ruler. So you can create a bar graph from data. So if we have data with the electoral votes per state, I think this might have updated on the last census, but I'll use the data the book has right now. And so we have a number of electoral votes. So I need to make a graph that can go up to 55. That's the largest number. So I'll draw my axes. And I'll put, tallies. And these should be in fives. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. In fact, graph paper is one of the best ways to do this. But since I have my screen here, I'll use my utilities. And then I put a bottom category for each state. I think Nebraska's NB. I always forget my state abbreviations. I used to work part-time sorting mail during the Christmas rush, and I should have these memorized. So Texas has 34, so I need to come right here for Texas and bring that down. California has 55, so I'll come here for California. Let me get my corner in the right place and bring that down. And then Florida has 27, so I'll come right about here for 27. Nebraska has 5. Indiana 11. And Georgia 15. And so the top of the bar points to the number. We'd intersect the number. And the bar itself is over the category. And so we can create bar graphs by having some data. And if we take 34, right, 34 matches the top here. If we look at Nebraska with 5, or let's say Indiana with 11, so 11's about here. If I mentally follow that line across, that hits about here for 11. And so the top of the bar measures out the quantity, and you can visually look and go, hey, look, California has the most, without having to talk about the number exactly. And graphs do this for us. They give us the ability to visualize information and quantity and to compare categories looking at it without having to dig into the number. It's a good way of representing data. Now, related to the bar graph is a thing called a histogram. And a histogram actually has 2 sets of numbers. It has a count of things. And so let's see, we're going to look at the number of students and their test scores. And so we'll count by 2s, 2, 4, 6, 8, 10, 12. And then what we do is we break the test scores into classes that have the same range. So we'll do 40 through 49, 50 through 59, 60 through 69, 70 through 79, 80 through 89, and 90 through 99. And so, let me see, we're counting by twos. And so this is the number of students, and this is their test score. And a histogram has no gap like the bar graph did. And so let's see, one student scored low here. So we have a bar that counts 1 in this category of test score. And then 3 students scored here. So this goes up to here. And then we had 2 students score here. And we had 10 students score here. So I'm going to color that in. And we had 12 students score here. And 8 students score here. And so this is what a histogram looks like. And let me see if I can color in a bit better. Try to use the paint tool to get my coloring in done. So make sure my lines are solid. Let's see if the paint tool works for me here. And so this is what histograms look like. Now the key point for histograms is the data here is also a quantity. There's a quantity here, and we divide it into equal sized bins or classes. And so there's 10 numbers in each class. 10 numbers in each class, and we'd say the class width is 10. And then this is usually the count of how many things fall into the class width, each class. Now histograms themselves will sometimes become line graphs, where you can take the point, the midpoint of each value, and connect them with a line. So we start here, we connect this line, and so histograms are related to line graphs when you read a value. You read a value at the midpoints, and you connect them with a line. What visually we should be looking for in both the histogram and the line graph is the space that fills underneath these curves. The space has meaning. It's telling us more stuff is where there's more space taken up by the graph. And so line graphs have a point that represent the average value. And so we could say, at which, what students have, what is the largest average value to the number of students. And well, we'd look here and go, hey, that's when the students are between 80 and 89, which is 84.5, right, is the midpoint, 84.5. And so that would be the largest average grade on this. And so line graphs, histograms really look on how we fill space. Bar graphs look for how long something is. The space left to right has no meaning. Where histogram, the space left to right has a value. All right, we'll continue looking at graphing and how value relates to graphing.